Introduction to Robotics video series. In today's video, we'll learn how to program a tilt ball sensor or tilt ball switch to turn an LED on or off. So today we'll start by building a simple circuit where the LED is connected to digital pin 7 and the tilt ball switch is connected to digital pin 4 on our microcontroller. If you're new to this technology, make sure you check out our last 3 videos to get you caught up to speed. We'll use variables in our code today to hold the pin numbers our LED and tilt ball switch are connected to. The LED is an example of an output since we can control it with code. The tilt ball switch is an example of an input. It will send an electrical pulse back to the microcontroller depending on its orientation. The tilt ball switch is more specifically a digital input, meaning it can only have 2 possible states. Here you'll see that inside the tilt ball switch are 2 metal balls. When the tilt ball switch is upright, the metal balls touch the 2 metal prongs, closing the switch and creating that closed loop. When the tilt ball switch is tilted, the metal balls move away and are disconnected from the metal prongs, creating a switch that's open. When we connect any digital input to a digital pin, the microcontroller has a hard time knowing what the initial state of that pin is. And so oftentimes it will fluctuate between high and low. In order to resolve this issue, we can engage a pull-up resistor that's inside of the microcontroller. From a code perspective, high is equivalent to the value of 1 and low is equivalent to the value of 0. In order to read the value on digital pin 4, we'll use a new function called digitalRead. This function takes in only one parameter, the pin number. digitalRead is able to read the voltage value on the specified digital pin. Now this function literally returns the number 0 or 1 depending on the orientation of the tilt ball switch. So we need to create a new variable to store the value that's returned by digitalRead. In order to view the value of tilt position, we're going to use the serial monitor. To do this, we have to include the serial monitor library in our setup function as follows. Then we can print the value by calling the function in our loop function. Serial.println will print the value of the tilt position on a new line each time. So that's what ln is for. So let's verify and upload our code so we can see what's happening. To view the serial monitor, we'll go to Tools, Serial Monitor. When our breadboard is flat and the tilt ball switch is upright, a value of 0 is returned. And when our board is tilted and our tilt ball switch is then tilted, a value of 1 is returned. So how can we use this information to now control an LED? This is where an if-else statement comes into play. An if-else statement in code is used to make decisions based on certain conditions. Here you can see the syntax or setup of an if-else statement. So first we have the word if, and beside it in parentheses is the test expression that's being evaluated. If the test expression evaluates to be true, then the code written within the if portion of the if-else statement, so the first set of curly brackets, will be executed. If, however, the test expression evaluates to be false, then the code written within the if portion of the if-else statement, it will be skipped over, and only the code that's written within the else block of the if-else statement between these two curly brackets will be executed. Within the test expression, you will be using a relational operator to compare one value against another. So I've shown a few here. For this project, we want to turn the LED on when the tilt ball switch is tilted and keep the LED off when it's not tilted. So we'll write an if-else statement to do that. What will you do with your tilt ball switch? Thanks for joining us in today's video. And if you enjoyed this video, make sure you check out our next and last video in this video series where we'll test out an analog input to control an output. See you next time.